go on the road. Okay, so everyone, let's wrap up this warm-up routine and then we'll get going. So immediately, I agree, the red square is 3. Now, if that is 3, then this must be 3. That must be 3. Do we know what the green triangles are going to be? What do they have to be? What does the triangle have to be? Something times 3 is 24. So something times 3, I think that something must be 8. But then what do the triangles have to be? What do the triangles have to be? What do these have to be? Well, I think 8 can be broken down into 2 times 2. Mbali, you're on the money. You are on the money. 2 times 2 times 2. Okay, so what's the final answer going to be then? You have to work out what the blue circles are, and then eventually, what's the final answer? Hi, David. Welcome. So if we know this is 3 and that's 2, what are these blue circles going to be? And then how do we take those blue circles and help us figure out this last bit? So David, what we're doing is, instead of a Maths 24 thing to warm up today, we are doing another different puzzle, like a puzzle question just to get going for the day. Yes, we are. And the puzzle says, 3 squares times each other gives you 27. We figured out that the red square is 3. We then figured out that the green triangle is 2. And we're trying to work out what the circle is, and then ultimately figure out what this is. So I think for this line here, 6 times something is 96, and I think it's 6 times 16, which means these 2 blue circles must be the same as 16, which means they must each be 4, which I see people coming through. Yes. So what is my final answer going to be? So if I go 4 plus 3 times 2, and I use BODMAS, I must multiply first. So I get 4 plus 6, and I get 10. And I see a lot of you have got 10. So well done, guys. I do like to, have an interesting start to the lesson if I can. Now, obviously, I'd love to get a feel for if you guys enjoyed that or not. So a thumbs up if you liked it, thumbs down if you felt like, didn't enjoy that. Just want to get a sense of the mood in the room around doing things like this in future. Yeah, I think it's nice to have some variety in our lives. Okay, fantastic. Okay, well, let's move on to the next part of the lesson. And obviously, we do try to follow up from things we said in the previous lesson, and also sometimes there's some admin. Also, just to welcome all our newcomers. I would really like to say a warm welcome. And if you're feeling a bit confused about the structure of the lesson, don't worry. It'll all become obvious with time. This is the 6th lesson in basically a course of 6 units. So this is the last lesson in this particular unit. But yeah, you should be able to follow along nicely. And then at the end of today, there is a fun quiz. But in order to do the fun quiz, you have to be logged in, or you have to have a login for the website. So that's something important. We will put the link to the quiz probably at about 1:45 or 10:45. So that's coming up at the end of the lesson, and you need to be logged in. And then also, if Watobe has a 2-week free trial, if you are at the end of the 2 weeks, your parents will get a WhatsApp or a message. And so if you have enjoyed using Watobe, please do let them know that you've enjoyed it, because otherwise they may be a bit confused by getting the message. And then they would have to make a payment to continue coming to the Zooms. And I think it's about 75 Rand a week, if I remember correctly. So that's just some admin. And then I'm going to hand back to Miss Anya. She also had some feedback from the previous lesson, some admin and announcements.
Okay, right. I'm just going to keep my video off. So from my side, we took in what you guys were saying about the factorization and all that. I don't know if for some of you that were on Monday's lesson, some of you mentioned you struggled a bit with factorization. So I'm going to post a link in the chat now to a Watobe video. Let me just type in Watobe. It's going to be a grade 10 video, grade 10 factorization. Please don't open it now. You can maybe just have it like saved or so. But that will take you to a quick like revisit or revision link to factorization. Obviously, you won't be able to watch it now because that's a whole lesson on its own. But that's something you can look maybe at later this evening or tomorrow or so. But thank you. If there's anything you guys need or so, just please reach out. That's why I'm here and reading the chat to see how we can help you. All right. Thank you.
Awesome. Okay, let's get going with the stuff. So basically, if we look back at this course, the things that we've covered, simple equations, and then we added equations with brackets, and then we added equations with fractions. So that's some of the stuff we've done. We then did simultaneous equations. We did quadratic equations. And then in the last lesson, and this is where I'm going to start today, we did inequalities. And I'm going to talk to you quite a bit about this, but the quiz itself today is going to be based around this type of stuff. Okay, so that's just a little recap in case you were feeling lost or you wanted to think back. I always think it's good to do that. Now, I want to start today by talking more about what an inequality is. So if I say to you, what is x greater than 3? We're going to focus just on this x greater than 3 thing. Could you put an answer to that inequality in the chat? I would love for you to put an answer to that in the chat. Give me something which x is when it's greater than 3. So anything in the chat, give me a number which allows x to be greater than 3. Give me an answer to this question. Cool. And I would love to see the chat light up. Aha, look at all those answers, guys. So I agree, 5 is an answer, 4 is an answer. Would 3 work? Ah, good question. 78, these all work well. Okay, so the thing about inequality is that it doesn't just have 1 or 2 solutions. It actually has many solutions. And that's why in the last lesson, I was saying that whenever you answer inequality, you often do it by having a number line and you show your answer with a number line. And so in this question, my answer is going to be all the numbers that are greater than 3. And the way I show that is I have a number line with 3 on it. I have an empty dot to show that I don't include 3. And then I have an arrow going in the direction of all my possible answers. Okay, so that is just how we illustrate the answers to inequalities. Now you'll see here that I have another inequality. And this inequality, it says 2x is greater than 6. Can you guys give me an answer to that inequality? Give me some answers in the chat now. We'll call this B. What values of x will be an answer to this inequality? And I'd love you to put this in the chat again. Could x be 3? Let's try that. 2 times 3 is greater than 6. Is 6 greater than 6? I don't, how? Well, give me a thumbs up if you think 6 is greater than 6. Give me a thumbs down if you think 6 is not greater than 6. Aha, I like it. Can you see there's a contradiction there? So it turns out that the answers to this question will be, some of the answers I saw would be things like x is 5 or x is 4, because 2 times 5 is 10 and 10 is greater than 6, or 2 times 4 is 8 and 8 is greater than 6. And you know what? In fact, this was actually the same inequality, because when you solve inequalities, you can almost use all the rules that are the same to equations. So let me try and solve this inequality using equation thinking. If you had to solve this as an equation, it's the 2 that would be causing issues. And so what you would do is you would divide both sides by 2. And if you divide both sides by 2, you then get x is greater than 3. And what do you know? That's exactly the same inequality that I just did above. So I was deliberately trying to show you that just like equations can sometimes look different but be the same equation, the same thing can happen with an inequality. Okay, so that was my little, just to get you started. But there's a warning. Whenever we are dealing with inequalities, there's one little sneaky thing that can happen. And I'm going to use this example here to help me illustrate this. If I write 5 is less than 7, I think most of you would say that that is correct. 5 is less than 7, no problem at all. But if I say to you now, I want to divide both sides by -1. If I do that, normally with equations, I can do that. There's no problem. If I divide by -1, what am I going to get? Okay, well, 5 divided by -1 is -5. And 7 divided by -1 is -7. Because now we're going to have why -1? Immediately, good question. Didn't have to be -1. I just wanted to choose a negative number. So I could have chosen any number, but I just thought -1 would be easier. So what I'm going to do is I'll do it again, just to make it a bit easier. I really want to show you with an inequality what happens if you divide by a negative. So let's just use 1 because it's simple. Here's the question. Is -5? So what I've done is I've divided this by -1 and I've got -5. I've divided 7 by -1 and I've got -7. And I want you to vote. Okay. Is -5 less than -7? If it is, give me a thumbs up. If it isn't, give me a thumbs down. So if you think it's true, if -5 is less than 7, give me a T or a thumbs up. If -5, if you think it's false, give me a thumbs down. Oh, you guys are too smart. You've realized this. Okay, now, if you look at the number line and you look at 0, and then you think, where is -5? It's here. And where is -7? You will notice that -7 is further to the left. And so this over here, this -5 is less than -7 is false. It's not allowed. And what I was trying to show you is that if you have an inequality, if you ever divide by a negative, you have to then switch the inequality sign to point in the other direction. So that's the one thing with inequality. Other than that problem, which you have to watch out for, inequalities can be treated almost exactly like equations. And then the only difference is they don't just have 1 or 2 solutions, they have multiple solutions, or we show them on the number line. Okay, guys, so that was my little trick just to be aware of. Let's go and practice this idea in a question. So I want you to try and solve this inequality for me. So this is everybody. I want you to try and solve this. We're not going to talk about interval and set notation for now. We'll leave that out of the picture. But all I want you to do is I want you to solve this inequality. And I'm going to give you 2 minutes or so to do this. So I'm going to take a break, and everybody is going to try and solve this inequality and then put it on a number line. And then I'll tell you the difference between set notation and interval notation. But let's solve the question first. So in the world of equations, I think the first thing we would deal with would be the bracket. And so that's what I want you to think about. From previous lessons, I normally have to start. I normally have to start by dealing with this bit over here. And then how would I go about solving my thing? I see lots of answers coming. Yeah, distributive law, exactly. So your first step is going to be doing this. And now, what do we need to do? So if this was an equation, wouldn't we try and get everything on one side and all the numbers on one side and the variables on the other? So I think we might do that. And then we might take away 3x from both sides. So we would get that. And then what we would do is we would take away 4 from both sides and we would get that. And so now the final step, divide by 3 on both sides and we get that. Okay, and I think most of you have got that. So then how do we illustrate this on a number line? So we draw a number line, and on that number line, we put a -3. Now, what direction is this going to be in? Well, X is the bigger part of the crocodile mouth. So I'm going to go up and to the right. Am I going to color in my dot? Does it include -3? Yes. So I color in this dot because it includes, and then it's going to go like that. Now, so give me I think most of you got that, so it's fine. Let me talk about interval and set notation. This notation over here is sort of, well, it's conventional set notation. It's what we're used to. But some people would write this in interval notation, and interval notation would look like this. It would say, on the one end, where does this start? It starts at -3. If it includes -3, there is a square bracket. If it didn't include -3, it would be a circular bracket. Semicolon. Now, how long does it go on to? And basically, it goes on forever. So it goes off to positive infinity. And then infinity can't have a square bracket. So it's always going to be like that. And so that would be another way of writing that, but that would be called interval notation. Okay, that's it, guys. Okay, I think that went okay. Let's do another one.
So,
yeah.
When you do the next one, do you mind just slowing down a little bit? Number 1, on explaining to kids the direction of the arrow.
Okay, perfect.
That's the first thing. And then I just want to see what else popped up. Just hold on. And just explain to them first when you do these, why we don't use an equal sign.
Okay, perfect, perfect. Okay, let's just start. I'm going to take Miss Anya's comments and try and incorporate them before we start the next one. I'm going to call this question B and this question C. Now, the key word for B is to solve this inequality. Now, at the moment, this is not an equation because there's no equal sign in between. There's this crocodile mouth. Let me zoom in even more. there's this crocodile mouth here, which is talking about the relationship. And it's saying this side over here is bigger than this side over here. And to solve the inequality, I want to find all the values of x that make this statement true. So that's, I know it sounds very wordy, but that's what I'm trying to do. Now, in order to solve this, the good news is we can follow a lot of the steps that we follow for equations, except that at the end, we won't just have one or two answers, we will have a whole bunch of answers because the answers will be a range on the number line. So I hope that that makes it a little bit clearer, but basically I'll start by letting you practice this one. And then for question C, what you'll notice is I give you a number line and certain parts of the number line have arrows or little bits of the answer written in. And what I want you to do is I want you to describe this in either interval or set notation. So I want to see how many of you can describe this in either normal notation or interval notation. But that's the second prize. The main focus now is this. So on your marks, get set, go.
So don't scroll down now because the kids are busy with B, but I see Ayanda's got their hand up.
Oh, yes. Go ahead.
I actually wanted to mention a question, but I'm rather just going to give the mic to them.
Perfect. Go ahead, guys.
Ayanda, you need to unmute yourself, please. Ayanda, we can't hear you. Oh, there you go. You're unmuted now.
Perfect.
Ask the question on the chat box. Thank you very much. I've lowered my hand.
Cool. Perfect.
And then, so I haven't calculated number B now, but maybe we must just also explain later on to learners, you know, when would it happen that we change the direction of the symbol?
Ah, okay. Yes. So the only time, look, there's ways that you can get around that problem. Sometimes by the way you move things around, the only time that you would change the direction of the crocodile mouth is if you have to divide by a negative or times by a negative. So whenever in an inequality, that's the only time where the normal methods break down, is when you basically when you do a negative thing to both sides. And that's what I was trying to show earlier in the lesson with that 5 and 7 example. But I'll point it out in this example when we do it.
Perfect.
So the first step is really just to distribute the brackets and watch out for that this is a plus, because a negative times a negative is a plus. Now, what you can do to avoid the problem of dividing by a negative is make sure that you always have a positive x value or positive variable value. And so I kind of do this automatically. I always try to end up with a positive variable value. And so what that's going to mean is it's going to mean taking this side and adding 4x to both sides. And when I do add 4x, the negative 3x will become positive. So let's do that. So we get 1 is greater than, okay, I'm leaving out the step, guys, but basically this disappears because I add 4x to both sides. And then I end up with just a plain old x hanging out. The 1 is still on the left-hand side. And what have I got left over here? I've just got my plus 33. And now I'm going to take away 33 from both sides because this 33 looks like it got lost. I'd really like the x to be by itself. So I'm taking away 33 from both sides. Maybe I should even write that in explicitly so you see it. I don't always write the step in, but I'm going to show you there. And what's 1 minus 33? So I think I'm going to take away 1 and keep going. It's going to be minus 32. And now I have x. So this is my answer. And what does that say? It says x is less than minus 32. And when I put that on a number line, Well, let's put a minus 32 here. Does it include minus 32? No, because it's not a greater than or less than or equal to. It's just a strict less than. And it's all values that are less than minus 32. And so that would be the answer. For those who love some interval notation in their life, what would it look like? So it basically is going to have negative infinity on the one side, minus 32 on this side, and then circular brackets like that. But my recommendation would be, unless you're very confident with interval notation, most of the time, most students would find that easier. Okay, can you get C? Can anybody put the answer for C in the chat? What does it mean when we have a number line? Basically, I want you to describe the inequalities that are here now. What does this mean if I had to translate this into an inequality statement? Notice that -1 is an open dot and 6 is a closed dot.
Sir?
Yes.
I tried to explain to the learners, can you maybe I know you've got C on the board, but can you just scroll up a little bit? So first question here is, someone's asking, is it the same as saying X is larger than negative 32? Can you please explain to them why?
So it's not the same, because X greater than minus 32 would be going this direction. So it's a different set of answers completely. What probably happened is that you had a point where your negatives got confused, or you made like a silly mistake along the way. And so you'll have more chance to practice the skill later in the lesson, but that would be incorrect for now.
Okay, thank you. And then the second question is, Nomuso also asked, I think a lot of the learners are getting confused by, I'll call it, when you start solving the equality. Guys and girls, just try to think of it. It's not the same, but try to think of it as solving an equation. Like, all the steps are the same. The only difference is you keep, your arrow or your crocodile mouth or whatever in the middle. Just try to think of it that way.
Okay, let's try and do C together. So I'm going to focus on this part and say, how do I describe that? For me, it looks like -1 is really important, and it gets less than -1 in the negative direction. So it's going to be X is less than -1, and it doesn't include -1 because of the open dot. Or I could say, what about this part up here? That part does include 6. And so I'm going to say that X is greater than or equal to 6. So the correct answer would be, this is how you would describe it in sort of set notation. Interval is a little bit tricky to describe. It wouldn't be -1 to 6 because these are separate intervals. And so you would have to describe these in 2 separate interval notations because they're separate intervals. So this is why I really like normal notation, because it's a little bit more flexible. Okay, let's do some more practice with this, because the more we practice it, the easier it will get. It's just a matter of repeated practice. I don't want to do that one. That's a bit tricky still. Let's take this one. And I'm going to blow it up so it is the center of attention. Oh, maybe that's a bit too big. And let's get rid of all the other distractions. Okay, look, it's a little bit too big, but can you solve this inequality for me? So solve this inequality and then put it on the number line. And if we sort of get this one right, maybe I'll then take it on to an inequality with fractions if we feel comfortable. But first, I want you guys to do this. And then when you get your answer, I want you to put it in the chat, please.
So just one question from the chat. I don't know if I probably missed it as well. Kelly Borne is just asking about the question for C, where we have the number line.
Yes.
What was the final answer for that one? If you can maybe just write it down.
Let me just quickly go and see what it was. Sorry, guys. It was this one over here. So x is less than -1, or x is greater than or equal to 6.
Okay, thank you, sir.
Cool. Now, where was I? Sorry, I must be making you guys dizzy. My apologies if you feel like you are. I've lost my. Oh, there it is. I promise I won't move this around. Yeah, have a go.
Oh, excuse me, sir.
Yes, go ahead.
So my question was, for number C, why would it not be x is an element of open bracket -1 comma 6 and then close bracket?
Yeah. The reason is, in that question, there are 2 separate intervals on the number line. So whenever there are 2 separate intervals that are being included, you can't write them as one interval because these are 2 separate intervals. So when you write -1 to 6 like that, you're saying that that's one interval. And it's so that's why it's incorrect. You can write it as 2 intervals, but that's going to take a bit longer. That's why I prefer the way of just using the set notation with something or something. So that would be my recommendation. Yeah.
Thank you, sir.
Cool. Okay, so if you were solving this as an equation, the first step you would have to deal with would be this. So let's start there and then see where we end up. And then I think we need to have a break.
So just help me out. I've hit a blank moment. When we, I know we probably not going to do this with these learners, but when we speak about infinity and notation, can infinity be included, or is it always a curly bracket? I can't remember now.
Bracket. So whenever you have infinity in set, because infinity is not a number so much as a concept. So you always, whenever you have an infinity, you might have a negative infinity, but it's always going to be circular. It can never be included. But for most students, I recommend the set notation just because of the simplicity and the chance of making less mistakes. Maybe later on, when you get comfortable with this, like interval is a bit quicker, but I rather take the reliable route is my preference.
Okay, perfect. Because I just wanted to show Kenneth in the chat how it would look like if it was written as 2 intervals.
Perfect. So that would be step number 1. And again, what I want to point out is I have a choice here. I could move the 4x across, but that's going to make my life very difficult because then I'm going to end up with a -6x, and then I have to deal with the minus, and they might be switching around. In fact, I will show you both methods. Let me do this question in both ways and show how I would have to do it if I did it like that. So, because I think it's a helpful distinction. So we'll call this method 1, and we'll call this method 2. Method 1 would be to add 2x to both sides, and then we get this. Okay, so I'm adding 2x to both sides, and then I end up with a 6x on the one side, and then there's that. I then add 12 to both sides. And I'm putting that in explicitly so you can see. And we get 13 is greater than 6x. Now, what is problematic? This 6 is problematic. So I divide both sides by 6, just like we would with an equation. And then my final answer is 13 over 6 is greater than x. Oh, sorry, x is less than 13 over 6. Now, let me show you how much more complicated it gets if we do it the other way. If we did it the other way, and we started by subtracting 4x from both sides, then I would get minus 6x plus 1 is greater than minus 12. Then if I took away 1 from both sides, I would get this. Now I have a problem, because this, well, it's not a problem if I know what to do, but I have to be careful I don't make a silly mistake. I have to divide both sides by -6 now. And if I divide both sides by -6, it's not a problem, it will work, but I have to do something special. I have to change the direction of my inequality. So if I divide both sides by -6, what I then get is x over here, but suddenly the crocodile mouth will be pointing that direction. It won't be going to the left, it's going to the right. And then -13 divided by -6 is just positive 13 over 6. Now I've got the same answer. X is less than 13 over 6 in both cases, but I think that method 2 is harder. And so that's what I would watch out for. If I was illustrating this on a number line, what would it look like? Well, the important number is 13 over 6, or on a calculator, I think that would be like 2 and 1/6, doesn't matter. X must be less than that, and it's not including the number 13 over 6. So it's an open circle and an arrow that goes like that. So guys, before I give you a little break, I just want a quick thumbs up if you feel like you could handle a little bit harder inequality. Thumbs down if you like, my brain is being maxed out right now. So, because I just want to know after our break if I should do something a little bit harder with inequalities. Not much harder, just maybe some fractions. If you could just let me know in the chat. And then what I want after you vote is I really want you to just stand up. And I want you to just, oh, I don't think pen flip today. I think just a good old fashioned click your neck, stretch your shoulders, and just get some oxygen going through your body, because this is tiring work. And so just stand up for a second. I do have some other brain breaks. What are the other ones? But I think I'll save them for another occasion. For today, just a straight stand up.
So sorry to budge in. I see Nazole is asking a question. What would the direction be if the answer was negative? So do you want to answer that question?
Okay, so is that hypothetical situation if the answer was negative? So if it was x is, I'm assuming that's what you mean. And all that would mean is you would go to a different place on the number line, because the number is now -13 over 6. So that's the only difference. X is still less than that. So it would be an open dot and go like that. So really just the number that you start from would be different, but everything else would be the same.
So sorry to interrupt. So just also something, as you showed that on the board now, if your x, something easier also to remember, if your x happens to be on the left side of your inequality after you've solved it, then, so for instance, if you looked at method 2, you could scroll down a little bit, sir. If you look at method 2, where Sir's x is in the final answer on the left-hand side, look carefully at his inequality and see if you can see a correlation between the arrow and where his line is.
Okay.
But this only works if your x is on the left. But that's just like a little pro tip. I wouldn't really always go by that, because sometimes most of you tend to prefer method 1 as well. Then it obviously won't work.
Yeah. Let us try and do this one over here. So we've had a nice little break. See if you can solve this inequality. Now I know the quality, I've zoomed in a bit much, But I want you to see, could you solve this inequality? Because this inequality has fractions. What tool would you use from your knowledge of equations to help you deal with an inequality like this? I'll give you, does anybody want to give us some tips? Ah, Namusa, you are on the money. Cross multiply, indeed, David. There's actually two ways you could do this. There's two methods. Both of them involve getting rid of the 6 and the 7 in a legal way. So if you could please go ahead and do that. And then once you've got the answer, pop it in the chat. I think for most people, finding the lowest common multiple, or the LCM, or the LCD, lowest common denominator, it will be LC. The number 42, because 6 times 7 is 42, may be helpful. That's one strategy you could use, because that number could get rid of these fractions for you. The other one that David suggested is cross multiplying, which essentially means that you could multiply both sides by 6 and multiply both sides by 7. But what do you get if you multiply both sides by 6 times 7? Well, you get 42. So it's essentially the same strategy. I want to give you a moment to try and do this. What do you get? The real problem in life at the moment is these fractions. How do I get rid of fractions without breaking this? And also, like when we were doing the lesson on fractions and equations, I always said to you, it's not a bad idea to have an insurance policy around your denominators. So denominators, numerators. So in this case, I already have a bracket up here. And I'm going to suggest multiplying this side by 42. Oh, those are too big. Ugh. Giant writing. No, let me undo that. It's too big. Let's change to pen. And let me change it to this. So what I was suggesting is you multiply both sides by 42. And the reason I would do that is that 42 essentially knocks out both 7 and 6. Some of you may prefer to do that differently, but that's the way that I would do it. Some of you may just go, I can do this straight away. It's going to be 7 times x plus 5 equals 6 times 4x plus 6. And that's completely fine as well. So both these steps, this is very quick and efficient. But both those steps will be fine. I'm going to do it slightly longer way just because I think it's a more reliable way. But okay, so if I multiply both sides by 42, then the wonderful thing is you can ask yourself, well, how many times does 6 go into 42? And the good news is it goes 7 times. And so I'm left with that. And then on this side, how many times does 7 go into 42? It goes 6 times. And so we get that. And so now let me just move. This is going to be the last question we're going to do for the day. So let me just move this out the way. We get to this step. Now, if you haven't got to this step, you've made a silly mistake along the way, and you still need to practice inequalities and equations with fractions. Let me just make sure I haven't made a silly mistake. Am I absolutely certain that 42 divided by 6 is 7? I feel pretty strong about that. What about 42 divided by 7? Is that 6? I feel pretty good about that too. So it looks like no silly mistakes will be happening. But now I need to distribute these things. So on this side, this is actually going to be 24 times x plus 6. And on this side, I'm going to have 7x plus 35. And then if I distribute this, oh my goodness, is that it's be a rather big number. What's 24 times 6? It is 144 if my times tables are good. And so now I have the same problem as before. I have an x on this side and an x on this side. So I'm going to take away 7x from both sides. And I get 17x. And then I'm going to take away 144 from both sides because I love this to disappear. And because it's late in the day, my brain is on holiday. So I'm going to use my calculator. 35 minus 144 is minus 109. So I get that. And then what is the last step? 29. I have to deal with the 17. Now I realize I'm going a little bit quickly, guys. I'm just going to finish this question. So I know that I may have lost some of you. I will stay on and take questions from you after this. How do I deal with the 17? I need to do the same thing to both sides, going back to the beginning of the unit, the equation and balance scale idea. So I divide by 17 and then x. I may need my calculator for this, but basically x is greater than or equal to minus 109 over 17. Hey, Kwanda, we are together on the same thing. So what does that look like on as a number interval? So I draw my number line. I put the number minus 109 over 17. Let's see if it's a messy fraction. So I'm just going to leave it as this. And then which direction is my thing going? Well, I know that the x is on the greater than side. So it must be going up and to the right, and it's included, so the dot is colored in. And so that would be my answer. Yeah. Okay. So I really have tried to give you a better sense of inequalities today. There are other types of inequality questions that we can practice on this, but what I try to do is just give you the basics of how inequalities are in some ways the same, in some ways different. You obviously can go and practice additional stuff yourself, but I'm going to call today's lesson and this course to an end. And what's going to happen now is Miss Anya is going to put the link to the quiz in the chat, and the quiz will take about probably between 10 and 15 minutes. And I'm going to let those of you who want to go ahead and do that, to go off and do that. You do not need to come back to class. So once you leave now and you start the quiz, do it to the end and then you're done. But for those who are feeling a bit uncertain and need a bit of extra help, I'm going to stay online and we're going to take audible questions from you at this time. And so if you could just raise your hand and then Miss Anya will come to you. And we'll take your questions. For those who are ready to rock and roll with the quiz, go ahead and give it a go. And just a reminder that these quizzes are, they're formative. They're just to give us a sense of what we're communicating with you and if you're receiving it. But so we want you to do the best you can, but it really isn't something to be overly worried or stressed about. Okay, I have said a lot. I have a bit of a hoarse teacher voice now. But I'm going to hand back to Miss Anya in case I've forgotten something, which I probably have. So, Miss Anya, back to you.
Okay, you guys should be able to hear me now. So I've posted the link in the chat. If you're having trouble accessing it, I don't know if we've got a few new students here tonight, but I'm just reminding you guys, you guys need to be signed up on the Watobe site. We do not use the Watobe app anymore. That's the thing of the past, only the site. I see David has his hand up. David, do you want to ask anything?
Please go ahead, David.
Sir, may I please go back to number B?
Okay, let's go back to this. And let me zoom out.
I didn't quite understand it.
Okay, to B. So this is this one on the screen now, David. Is that the one we're talking about?
Yes, sir, this one. Where did the one
Okay.
come from?
Okay, let's do a quick little review of this one. So where did the 1 come from? So at the very beginning of the question, there was a 1 over here to start with. So that's the first thing. The 1 was always around from the beginning. And then I distributed these 2 brackets, and that's how I got these things here. Okay, so that's the first step. So are you with me so far there? Cheers,
Yes,
everyone.
sir.
Okay, so now the next step, David, is I added 4x to both sides here. And when I add 4x to both sides, so let's actually do that. 4x on this side and 4x on this side. That is doing the same step. Yeah. Oh, yeah, I can see a lot of you guys are leaving now. Cheers, Jared. Cheers, everyone. I'm just going to finish with these questions, but it was lovely teaching you today. And I look forward to seeing you again next week. Okay, so what we have is that gets knocked out. And now the 1 is all by itself. And it's left on this side, minus 3x plus 4x is x. So that's these 2. And then I've got this 33. And now I have to deal with this 33. David, are you with me so far?
I don't quite get it. So how did the 3x cancel?
Okay. So if you take minus 3x and you add 4x together, essentially what you're doing is you're saying minus 3 plus 4. And so minus 3 plus 4 is just going to be 1x. And that's the 1x that is down here. That's where I've got it. Can I suggest that if you, another thing we can do, David, is if you just give this a little bit of time for your brain to settle on this, and you re-watch this clip again, you may also find that it would make more sense. Because it can just be like a little thing here or there that your brain just needs a moment to just relax and then go from there. Emikle, you have a question? Go ahead.
So could you please explain how, when you have to change the direction of the arrow again?
Yeah,
Yes.
okay. Let me make up an example for that. So say I have an inequality. Well, let me choose black pen just to make it easier. If I have something like this, most of the time you can avoid dividing by a negative, right? So the way I would avoid dividing by a negative is simply making sure that I'm rather move this minus 3x across, because then it becomes a positive on the other side. However, sometimes you will move things around. If you chose instead to work with the 4x, then you're going to end up with a negative that you have to deal with. So let's do that just to make, just explain this point. So what I'm going to do is I'm going to take away 4x from both sides. And if I do that, I end up with minus 7x plus 1 is greater than 7. Let's make sure my 7s actually look like 7s. Are you with me so far, Mikle? Okay, so I now am going to deal with the 1 by taking away 1 from both sides. And now I end up with a 6 on this side. And now I am forced to deal with the minus 7. In this case, I am going to divide both sides by minus 7. But when I do that, I have to switch the crocodile mouth around. So minus 7 over minus 7 is 1, and I get left with an x. But instead of it going this way, the crocodile mouth switches. And then I get negative 6 over 7 on this side. Okay. And so I hope that that helps. Yeah.
Sorry. So whenever there is a negative in either the denominator or the numerator, the arrow must always change.
Okay. This is the way I would describe it. Can you see that I divided both sides by negative 7? Whenever you do the same thing to both sides and it's negative with an inequality, you then switch the sign around. But my best practice advice is just avoid ever having to divide by a negative, because of the way that if you chose at the beginning to add 3x to both sides, you would never have to divide by a negative, and so you can avoid that. Okay, so that would be my tip. Okay, I think we're going to start to finish off. I do want to just say well done to everyone. That was, again, another good lesson. And it was nice to teach you tonight. And is there anything else from you before we finish off? Okay, so I think
I was muted. Sorry. I see there's one hand from Anele.
Okay, Anele, what is your question?
Anele, you need to unmute yourself.
So regarding the scale, how do you know which direction is it pointing at? Like, for example, when we were working on,
like something like this. Like, how do I know which way this goes?
No, sir, the direction of the scale when you drawing the scale.
Okay, let's do this example. The number involved here is I'm looking for all values that are greater than -5. So all x's that are greater than -5. So I put that on the number line. And then what I do is I say, look, it's not greater than or equal to, so there's going to be an empty dot. And so now the question is, which way is it going? Well, when you think of a number greater than -5, like a number 7, wouldn't the number 7 be on this side? And so I want all the numbers that are greater than -5. That's what this says. And so my thing is going to be pointing in that direction. Whereas for the second one, the second inequality here, in this case, I've got a less than or equal to. So in this case, -3 is included. And now I want all the numbers that are less than -3. So where are the numbers that are less than -3? They're like -7, -10. They're all going to be on that side. And so that's why it points in that direction. Okay. So that would be my short explanation of that.